QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let us try this function here. First question, what is the vertex of the graph of the given function? The vertex is at 0, 3. Next question. What is the axis or the line of symmetry of the graph of the given function? The line of symmetry is at x equals 0. And for the last question, how many x-intercepts are there in the graph? And if there are, what are they? We have 2 x-intercepts, and we have negative square root of 3, 0, and square root of 3, 0. Did you get 3 over 3? If not, please continue viewing this video. Let's start by discussing the process of solving the vertex, because once we know what the vertex is, we can always connect it to the axis or line of symmetry, because without even drawing the graph, we can automatically solve for the axis or line of symmetry using the vertex. Now, the third item, which talks about intercepts, there's another process to that. It also uses a specific process with regards to that was already discussed in the previous videos. But let's start again with the vertex here. The vertex is also known as the point of inflection, or it is where, or it is a part of the graph where the graph changes its direction. By the way, the graph of a quadratic function is a parabola or a parabolic graph. We can determine the vertex using the correct coefficients of our function. The coefficients are just the same as the coefficients of our equation. So we have here the A coefficient, the B coefficient, and the C coefficient. So A coefficient here is the coefficient of your x squared, and since we have negative x squared, our coefficient A is negative 1. Our B coefficient is a coefficient of x, and there's no x term here, so the coefficient B is 0. And our constant, which is our coefficient C, that's our 3. Now we can use these coefficients in solving for a vertex. Our vertex is a point in a graph, hence it's a combination of an x and the y coordinate. The x coordinate of our vertex is known in this shortcut, negative b over 2a. In short, simply plug in here the values of b and a, and you will get the x coordinate of your vertex. For your y coordinate, you have 4ac minus b squared all over 4a. So simply plug in the values here as well so that you will get the y coordinate. However, you don't need to stress yourself so much on this. You just need to get the x coordinate, and whatever the value of your x coordinate is, just like any other points on the Cartesian plane, input that on our given function, and the result would be automatically the y coordinate. Okay, so you don't need to memorize this. So let's start now by identifying the x coordinate of our vertex. Again, it's negative b over 2a. Our b is 0, so negative 0 over 2 times negative 1. Now, no matter what's the result of our denominator, since our numerator is 0, our x is 0. This is the x coordinate of our vertex. As mentioned, let's substitute such in our function to get the corresponding y coordinate, because f of x is also known as the y value. So you have here negative x squared plus 3. So you will substitute 0. This will become f of 0. So negative 0 squared plus 3. That will give us, of course, that's 0, a value of 3. This would mean that our vertex is at point 0 and positive 3. This is where the graph changes its direction. So again, we are not really required to draw the graph here, but just for discussion purposes, let me try to come up with a sample graph of this. This is, of course, our x-axis. This is our y-axis, or for functions, this is also known as the value of your f of x. So you have 0 and 3. 1, 2, 3. This is our vertex. So our graph will change the direction here. Now our graph could be either upward or downward, but more specifically, it could be given to us by the value of our a. You might want to review the previous videos on that, because if our a coefficient is negative, our graph will open downward, or the concavity is opening downward. This is our graph, the parabolic graph. We actually need at least 5 points for you to be able to see the parabolic graph. Well, the purpose of illustrating this here as well, again, aside from the point that the vertex is the point of inflection because it changed direction here, we could also try to discuss here the connection of the vertex to the axis, or the line of symmetry. Line of symmetry, from the name itself, is an imaginary line that can be drawn on our graph, which will divide our graph into two mirror images. The left and right images would be mirroring, meaning they are just balanced. So the axis of line of symmetry in this graph is this axis here. If we're going to draw this line, it divides our parabolic graph into two mirror images. And we are to get because we are talking about line in our Cartesian plane, it's an equation. We are going to get the equation of this vertical line. In our previous years in grade 8 math, you were able to understand that if the line on our Cartesian plane is vertical line, its equation starts with x equal to something. That something is the point on the x-axis where that imaginary line or vertical line will intersect. In this case, where that axis of symmetry will intersect. This is the x-axis here. So this is the point where our line of symmetry will intersect. Now here's the shortcut. Even without this illustration, as mentioned earlier, because we are not really required to do this, but even without this illustration, just by your vertex, you can automatically get the axis or the line of symmetry. And since we're talking about x equals something, it's the value of your x coordinate. So the x coordinate of your vertex is automatically your axis or line of symmetry. Just like here, this is your value of x. So just simply duplicate that here. Our axis or line of symmetry is patterned to our x coordinate. This is where the axis or line of symmetry is connected to our vertex. Now let's proceed to the last concept that is part of this video, the intercepts. Or more specifically for this video, we're talking about x-intercepts. The x-intercepts are a point in our graph where our graph will intersect the x-axis. Hence, it's called x-intercept. If the line or if it's y-intercept, then that graph intersects the y-axis. But here, x-intercepts. Looking at our graph, again, we're not really needed with this one, but just for illustration, we see there are two intersections here, and here. Our graph or parabolic graph intersects the x-axis at exactly 2 points. This would mean that we have two x-intercepts. Hence, the answer to the question, 2 x-intercepts. But the next question concern rather is, what are these intercepts? Now here's the hint. Your x-intercepts are equal to your roots. Once you will get the roots of your quadratic function, you can now get the intercepts. And how many are they? There are 2 of them. Okay? So let's try to solve for the roots of our given function in terms of its equivalent quadratic equation. So equate it to 0. Negative x squared plus 3 equal to 0. Of course, we have this quadratic formula, but we can just simply use here by extracting square roots. So let's move the constant on the other side. The positive 3 will become minus 3. Multiply both sides by negative 1. You will have x squared equal to positive 3, right? Here, we are going to take the square root of both sides. We can always do this process of solving the roots whenever we have or we don't have b coefficient. Just like earlier, we don't have b coefficient. So we have here the x is equal to positive and negative square root of 3. Let's just stay in radical because this is a irrational number. Hence, our roots are positive square root of 3, and you also have negative square root of 3. We have two roots now. As mentioned, we have two intercepts, so we also have two roots. But since our intercepts are point on the graph, so we are going to come up with the point of this. These are called intercepts because they intersect the x-axis. Hence, the y-coordinates are 0. And you simply plug in here your roots. So the intercepts are positive square root of 3 and 0. And we have negative square root of 3, 0. These are the intercepts of our quadratic function taken from the understanding of the roots. Now all of these are the discussions for the answers in this QuadQuiz. Subscribe now!